So let's go ahead and look at Bullet. It features discrete and continuous 3D collision detection and enables the simulation of both soft and rigid bodies in a single system while using a rich set of constraints. The first thing that we want to do with Bullet is use it to generate some dynamic secondary animation on this character's tail. So we'll go grab the joints of the character's tail and create a ragdoll from them. Basically what Bullet's done is it's gone through for each joint and created a collision object and then joined those collision objects together with constraints. The constraints have the ability to look to the original skeleton's limits to adjust how much movement they're going to have. That combined with dampening values goes into making the overall look and feel of the ragdoll. So let's go ahead and clean up our display a little bit and play back our animation. And you can see that we now have this cool dynamic secondary movement on the character's tail, but it's passing through the ground plane. So this is the first thing that we want to fix. And we're going to do that by creating a new rigid object in our scene. This time it's going to be a static rigid body that's just an infinite plane. So obviously now if we play it back, the tail no longer passes through the ground. Next, what we want to do is create a relationship between the skateboard and all this trash. We're going to create active rigid bodies from all this based on the mesh. So let's go ahead and just grab all these pieces of geometry and create, get that guy too, create more rigid objects in our scene. So now that we've made those active rigid bodies from those meshes, if we play back our animation, you'll see that there's a couple problems. First, the skateboard drops to the ground, and notice the movement of these objects. They're kind of floaty. So what we want to do is fix both of those problems. It's really simple to do. We'll grab the skateboard and we're just going to switch the type of rigid object that it is. Instead of being dynamic, we're going to push it back into a kinematic rigid body. So it's going to go along for the ride of that original animation. I'm going to go and grab the solver and increase the gravity so that those objects don't look quite so floaty. So now if we play this back, notice the effect on the tail. It's getting sucked down because of that higher gravity and those objects no longer float. So that simulation looks pretty cool. There's still one problem. We have a bag of chips that's floating up here in the sky. So what we're going to do for that is create a soft body. So we'll go and create the soft body of the bag of chips. And I want to change a couple of the parameters for this soft body. And I'm going to use a preset to dial it in. Essentially all I've done is increase the stiffness a little bit, the resistance a little bit. And I've turned on volume matching, so it's going to try to maintain a little bit of that volume. So now if we play this back, notice the interaction. When that comes down, the soft body collides with the rigid body. And it's a very cool dynamically driven simulation. The last thing that I want to do is just increase a couple of the attributes on these tail rigid bodies. I'm going to go and give them a little bit of push up in Y. So we'll just put a little Y impulse on those and we'll play this back one more time. So this really is what Bullet's all about. Soft bodies interacting with rigid bodies, constraints holding together collision objects generating ragdolls, all happening very, very quickly and interactively inside of Maya.